Assalamu alaikum dear students. Today we are going to start a new topic, that is atmospheric pressure. First we will start from the introduction, that what is a pressure. Pressure is particularly useful for dealing with fluids. We have discussed in the previous topic that what is the fluids. Those fluids is which flow from one place to another place, like liquid and gases, not a solid. Solid is not a fluid, liquid and gases are the fluids. It is an experimental observation that fluids exerts pressure in every direction. This is well known to swimmer and drivers who feel the water pressure on all parts of their bodies. A person need not underwater to experience the effect of the pressure. Walking about on ground, we are at the bottom of the earth's surface, which is a fluid and pushes inwards on our bodies just like water in a swimming pool. Now we are going to discuss about what is atmospheric pressure. The pressure that atmosphere exerts is called atmospheric pressure. Now first question, that is what is atmosphere? Atmosphere is actually a blanket of gases which surrounds earth. There is another definition that the earth is surrounded by the layer of gases called the atmosphere. It is the area of air around any location. Air refers the earth's atmosphere. Air is a mixture of many gases and tiny dust particles. So simply we can say atmospheric pressure is air pressure or pressure exerted by air. Look at this one diagram. In this diagram I am able to see clearly that warmer air comes to downwards and the colder air is going to upward. The high air is always flow from higher concentrations to the lower concentration. In the lower side there is a concentration is low. That's why the higher air comes towards down and the lower going to be into the up. Now pressure of the air at the given place varies slightly according to weather. At a sea level, the pressure of atmosphere on average is 1.013 multiplied by 10 raised to the power 5 Pascal. Pascal is the unit of the pressure. This value lets us to define a commonly used of unit pressure. Now, such as a 1 atmospheric pressure, the ATM is the symbol of the atmospheric pressure. We are going to represent ATM through the F for atmospheric pressure. 1 atmospheric pressure equals to 1.013 multiplied by 10 raised to the power 5 Pascal. Another unit of air pressure sometimes used to meteorology and the weather maps is called the bar. Such one bar equals to 1.000 multiplied by 10 raised to the power 5 Pascal. Note, there we have taking a letter word that meteorology. The question is that what is the meteorology? Meteorology is the branch of science deals with the atmosphere, climate, weather, etc. Thus, standard atmospheric pressure is slightly more than 1 bar. Understand that standard atmospheric pressure is slightly more than 1 bar. The air around us exerts the force in all directions and opposed by an equal pressure inside our body. Thus, we are generally unaware of it. However, when the air is pumped out of a sealed can, atmospheric pressure produced in inward force that is unopposed. The result collapse of the can insulates the pressure that in all around us. Now, atmospheric pressure at altitudes means at height. Now, the climates at high altitudes encounter lower atmospheric pressure due to thinner air. The thinner air causes breathing difficulties due to the lower level of oxygen. So at altitude, atmospheric pressure is low at the land or sea level means ground level. Atmospheric pressure is high. Look at this one diagram. First, you can look on this one side. Clear? These molecules contribute to the pressure, means weight, at this altitude. Clear? आपका जो molecules हैं, it's contribute to the pressure at this altitude, and these molecules contributes to the pressure weight at this altitude. Look at the diagram that in a lower region there is more molecules as compared to the higher region. Now that surface air pressure, yeah, the surface air pressure equals to the weight of air in the column above unit area. Now, using atmospheric pressure to crush can. Now the question is that before the air was pumped out, the pressure inside the can equal to the outside. So we are taking a thin wall pressure can. Clear? But there is a must that a can has a thin wall. Take a thin wall can. Before the air was pumped out, the pressure inside the can is equal to the outside atmospheric pressure. As the air is pumped out, the partial vacuum is very low from inside the can, and immediately the exert atmospheric pressure crush can. It will only happen if the material of the can is thin or flexible. This happened just because of the wall of the can is thin. That's why. Now look at this one diagram. Here they are exerted a pressure on this can, and look at the wall of this one can. Why that the can wall is thin? Crush the can with a vacuum pump. If we are applying a vacuum pump, what going to happen? If the can wall is thin, that it going to be a change like this at measurement of atmospheric pressure. An instrument that is commonly used for measure atmospheric pressure is called mercury barometer. Now, Italian mathematician Evangelista Torricelli in 1607 to 1647 invented it. In 1643 he invented a mercury barometer. In 1643 it is also called Torricellian barometer. So what going to happen? Construction and working. There is a one long tube open at one end and closed to the other. It is filled with the mercury and then inverted into a dish of mercury. Once the tube is inverted, the mercury does not empty the bowl into the bowl. Instead, the atmosphere exerts a pressure on the mercury in the bowl. This atmospheric pressure pushes the mercury in the tube to the same height edge above the bowl. So what going to be happen then? The tube in which there is a mercury on the bowl of the mercury by atmosphere is equal to the weight of the column of mercury in the tube. Any change in the height edge of the column mercury means that the atmosphere pressure has changed. The sea level, the atmosphere will push down on the pool of mercury and make it rise up in the tube to a height of approximately 760 millimeter. Mercury barometer. If there is no air in the tube, the air pressure on the mercury in the bowl forces the mercury to rise up the tube. The pressure at the bottom of the tube is equal the air pressure. The height the air pressure, the higher the column of mercury. Look at this one diagram. This is the tube, but this is the inverted tube. When we invert the tube in the bowl, what going to be happen that mercury has a dense, they are heavy density. That's why they are going to be silted down. You are able to see in the top of the empty space. This one is the empty space. This empty space occurs just because of that the mercury is a heavy density. They are going to be settled down. Look at this one red arrow. Are you able to see that a red one arrow? Okay, this red arrow has on a 760 millimeter. Atmospheric pressure pushes down on mercury. Look at the blue one writing. Atmospheric pressure pushes down on mercury, and this one is this small space comes here. The scales indicates air pressure. Mercury rises up the inverted tube. Now, there is that it is possible to build a barometer with water rather than mercury. The question is that always we are going to take a mercury. Now the water, we are not taking a water because the water has a low density and the mercury has a heavy density. Then mercury air pressure is lifted contain a volume of water much higher up the tube than the same volume of mercury. In other words, if we use a water, he will need a really tall tube. In our barometer will be enormous, too much tall as a impractical. So we have read it about the it. Thank you. Allah Hafiz.